Hello guys, my name is Piers and today I want to talk about a very simple advice that I genuinely believe that it will make you a better engineer, especially if you are in that mid to senior level or if you are already a senior engineer. I think it will really help you. So the advice is very simple. Every time you make an IO call in your code base, just think what will happen if that IO call fails, because they are IO calls and they do fail. So let's see some examples. We process an order. We have a create order handler in which we inject an iOrder repository. So we take the order, we create it, and then we save the changes to our database. So if that save async method of the repository which calls the database fails, well, the whole order will fail. There's nothing we can do about it, no side effects, anything. If our system is done, we can process orders. It's fine. Now let's see in a second example. I have a create order handler again, and now I inject an iOrder repository and an iInventory repository. So in this case, we create the order, we save the changes to our database, so we have a new order in our database, and then we retrieve that item that was in the order. We decrease the quantity by 1, we update it, and then saving the changes to database. So what if that inventory repository.saveAsync method fails? We have processed our order, we have an order, but we didn't decrease the quantity in the inventory. So now our system is in an inconsistent state. We ship the order and we think that we have 3 of that items in our warehouse, but we actually have 2. So that can be again very simple since we are in the same application. We will begin a transaction right here, so begin transaction, and then if all of our calls to the database succeed, we will commit that. Otherwise we will roll back. So probably you already know about transactions, but that probably will make you see other things, like we have to do a transaction in every handler that we need that. Maybe there is a better way. Maybe we can have a middleware, let's say, begin a transaction and commit the transaction in there, and also catch any exceptions and roll back in one single place. Or maybe you don't want to have in the create order handler the order repository and the inventory repository and make all that calls in the create order handler. Maybe when you create an order, you publish an event, and then as part of the same transaction you have another order where you update the inventory. So by just adding a transaction somewhere you need it, you can see a lot of other things and patterns. So let's go to our third example, create order handler. Now our inventory service is another service, it's not the same application. So we inject an iInventory gRPC service, so we create our order, we save that to our database, and then we make a call to the other service through gRPC to decrease the quantity of that item. Again, we have the same problem. If that call fails for whatever reason, maybe it's a network error, maybe the inventory service is down, we also have that inconsistency in our application. So what do? Do you really want those 2 calls to succeed or fail together? If yes, probably they should have been in the same service and use a transaction, or maybe not. But then you go to the business, you talk about that, and the business says, wait, we don't want that 2 operations to be together. If we create an order and we were about to take the money for that order, we don't want all that to fail just because we can update the inventory at the same exact moment. So maybe a delay is okay with that. So you discover things like eventual consistency, or maybe asynchronous messaging. Because in my fourth example, I have a create order handler, and we again have the order repository, and also we have an event publisher. So what we do now is that we create our order, we save our changes, and then we publish an event. So we have accepted the order, everything is okay, and we have published an event that even if the inventory service is down, it will handle when it's back up. So we accept the order and we do not depend on that other service. But again, that publish async method is an IO call. So what if that publish async method fails? because of a network error or anything else. Again, we have that in consistent state. We have accepted an order, but we haven't updated the inventory. So then you try to solve that, and you see things like the outbox pattern. So what you do, instead of publishing event, again we'll begin a transaction. So begin transaction. You will also save the event, and then you will commit the transaction. So we will save that event together with our order as an atomic operation, and then we can have a background service to publish that events asynchronously. So you learn about the outbox pattern. Maybe if you go that road, you will learn about the inbox pattern as well. Also, maybe you step on background services, and what about if we have 2 instances or 3 of our services running? How we can deal with background services then, and maybe we need another project just for running those background services. And not only that, because again we will have a transaction here, we will commit the transaction, we will save the event. It's a lot of code that maybe the create order handler doesn't need to know. So you can have it more clean again by having some kind of domain and integration events that you handle them or in one place, so you can make your code cleaner, and again then you will see other design patterns. So what I mean is that by just thinking about what will happen when an IO call fails and how we can handle it, not only we are bulletproof that our system will be always in a consistent state, and we won't have moments like, oh, we thought that we had that item ready to ship, but actually we didn't. What happened? Let's go to our logs and to our telemetry and check what's wrong and update that somehow. And also maybe compensate the client because they thought that they could have it in a few days. So except from that, for making the system always in a consistent state, which is a big deal, you can always learn new design patterns, write cleaner code, make you a better engineer, and it also can help you make better architectural decisions because of the discussions with a business that start up from thinking what if that call fails. So that was my advice. It's a simple one, but I encourage you next time that you implement a feature or you look at your code base and you make an IO call, think what will happen if that IO call fails. So that was it about this video. If you liked it, please like and subscribe. Thank you for watching and have a nice one.